Of this set is equal to 1. I know that somebody won, but I would say that I'm probably interested in who won. And so in this case, I may want to check specifically for X and O. Now, we also do need to think about how this game might change in the future. If I'm not limited to just X or O, I may need to account for that. But at the same time, right, if I don't know who won, then I may need to see what is currently in the row. And I can also think, if I have some values that aren't played, say nobody in this game, nobody happened to play along the first row, I do also want to account for that as well. And so we have this little bit of a conundrum of how we manipulate these values. So if I have a space where a player has not made a move, that could be represented by here by a dot or even by a none value. I would want to know that in advance in order to figure out if somebody wins. And so I need to keep track of where people have not played to make sure I don't accidentally say that a given player is a winner. So let's take a look here. If I take the original logic that we had, I would print my row, my I, and my row, as well as the set of my row, just to see who won. We can see that in this case, our dots won, which doesn't really make any sense. So let's change these back to X's and O's here. And I'm looking for an X victory on the top. It looks like we captured that correctly. What if we have a third player? So we have maybe W's instead of X's and O's. Well, if I have a W here, it looks like our logic is holding up. So for the most part, checking the length of our set is going to help us identify if somebody has won, but we also do need to disambiguate if no one or if nobody has made moves on those values. So I could do something like this. If I'm nervous that nobody played along the top row and I don't want to actually capture that as a winner, I could say that my unique row, or my sets of my row, I'll use this as a variable that I'll access later. I could say that this is going to be my set, and I'll subtract away that player that I am not interested in, or that null move, where nobody has played. And so I just want to show you what this looks like. And we'll of course print this out. Now, if nobody has played on a specific row, I simply have an empty set. And that will, of course, not trigger my length check. So I could check the length of my unique row, and I could say if that's equal to 1, then we can print out our row and our unique row here. And so let's go ahead, we'll change these back and say that X1 here on the very first row, and it looks like this is going to work for us because we didn't capture a victory where nobody had played. And if I have a third player, and we have W's, it looks like W will win here. Of course, if I don't have a win, that looks like it's working. Now, what I'm actually doing here is I'm not necessarily just writing some logic against my rows. I'm actually writing some logic to determine who has won. And so I may want to abstractly refactor this out and say def winner, and this will take a single row or a single column, any span of 3 or more values. So this should be a single entity or a single list with no levels of nesting unto itself. For now, I'll call this a row. I may want to come back and call this something a little bit better. And of course, I do not want to just print out things when determining winner on my row. I actually want to return something that makes sense. So we have a few options. I can return whether or not this row won. I could return something like a Boolean, return true, and otherwise return false. Now this doesn't tell me, and I'll print this out here. This is telling me that on my 0th row there was a win, and then on my 1st and 2nd row there is no win. This is good for having very not very dense logic, but at the same time, I'm also interested in who won. And so I could return, right, who the winner was, and maybe an empty set if there is no winner. In this case, I could return my unique row, and I may even do something like this. Since I know there's only a single element in my unique row, I could return, right, the only element in that set. I could do something like set.pop or just grab the first element out. The thing I don't like about this is it makes these values very clumsy to work with in my output. Meaning, I could say winner is equal to the victor, right? The individual player who won is equal to the winner of the row. But then, chances are, if I want to do anything with this victor, the very, very first line of code that I'm going to have to write is if is instance victor, right, comma set. If it is a set, nobody won. If it's not a set, somebody won. And this is a little bit clumsy to write. So what I'll do is instead of returning, right, heterogeneous values here, meaning values or having my function return have sometimes a single string or sometimes a single entity and sometimes an empty set, I could return two values, right? Whether or not a win was detected and a second value determining if that person won. And in this case, I could even go so far as returning, right, my set of my non-player, my null move here. And we'll probably need to revisit this logic, but now I'm returning two values every time that I detect a win. And I can even unpack this, so I could do something like this. I could have my whether or not somebody won, and then who that victor is. And then now, instead of checking the instance, checking if it's a set, I could say, if somebody won, print, right, victor won on row, and then we could use use a little f string format here. So x won on row 0. And that would start satisfying my logic here. The nice thing about this is I can even check, right, I can enumerate my columns as well. And remember, my columns is just my transpose of my board here. The last thing I want to do is just swap out row for col, just like that. So we know that somebody won on row 0, and let's see, x also won on column 0. Let's see if we can get O to win somewhere as well. So maybe O won on the bottom row here. And we'll even have O win on the first column or the second column. And you know, this logic looks like it's holding up to me. So I'm quite pleased with this. I may even abstract this just one more level. And I may have a function called rows that takes an input of my board and just returns, right, each row. In this case, I could just return the board itself because, right, our board is already in upright position. But this would give me parity because I could also have a function called columns, and the purpose of this function is to yield from or produce each column. And this would just yield from the board. The nice thing that I like about this is I can also, of course, compose these two elements. And so I could iterate over my rows and my columns and just chain them together. I do lose a little bit of fidelity of, am I looking at a row right now or am I looking at a column right now? So I think we can keep the code in the same state that it is currently in, and I'll just enumerate my rows on my board. Now, I could have my rows be responsible for the enumerate itself, but I like to keep that a little external to here.